And here's a statement. This statement was proved by Euclid about 2000 years ago, that there are infinitely many primes. Okay? And you'll see that we use kind of case-by-case analysis and some contrapositive things while trying to prove this. Okay? So let's do this. It's kind of a very beautiful proof. And here's the proof. I now want you guys to be able to figure out the justifications for each step. Okay? People who haven't spoken a word today, raise hands. Oh, everyone was start today, really? Yeah. I only see one hand. Do I have any other? Second last row, Kinder. So let me ask the question again. The question I'm asking is that I constructed a number in the second step. I said multiply all of these primes, जितने भी primes है सबको, और इसमें 1 ऐड कर दो. Okay? और फिर मैं ये कह रहा हूँ कि थर्ड में कि n is not a prime number. How could I say this? No, I know. I'll come back to you. But this is the question for the second last row. Okay, go ahead. जोर से बोलो. Be more succinct. Okay? Be more concise. But I'm saying that n is not a prime number. Okay? But लेकिन मैंने +1 किया यहाँ पे. लेकिन प्राइम नंबर्स में तो 2 होता है ना. So let's say कि आपके पास सिर्फ 2 प्राइम नंबर्स हैं, 2 and 3. Okay? 2 times 3 is 5, 5 plus 1 is 6. 2 times 3 is 6. Oh, 2 times 3 is 6. Such stupid of me. Okay, cool. But that's not the justification for this step. Okay? This is much easier. Okay? So what I'm saying is that I picked up a bunch of numbers, multiplied them, added 1. Okay? I'm saying this is not a prime number because it's not one of the numbers जिनसे मैंने start किया था. मैंने ये कहा था कि this is all of the primes, है ना? And capital N is not one of them, है ना? That's the justification for saying that N is not a prime number. Okay? Are we good? Okay? मैंने पहले कह दिया कि ये 5 नंबर हैं प्राइम, इनको मल्टीप्लाई करो, उसमें 1 ऐड कर दो. अब ये जो नंबर है, this is not one of these 5 numbers, so it must not be prime. So देखो हम ये प्रूफ कर रहे हैं कि there are infinitely many primes. हमने उसकी negation ली और हमने कहा कि नहीं, there are finitely many, and we have gathered them all. This is all the list of prime numbers we have. Okay? अब कोई नंबर अगर उससे बड़ा होगा तो वो तो प्राइम नहीं होगा ना, क्योंकि सारे प्राइम्स हमें पता हैं. Alright? Okay? So we kind of सारे इकट्ठे कर लिए ना, I don't know. Okay? तो उसके बाहर तो नहीं हो सकता ना, उस सेट से बाहर. Okay? So yes, so capital N is not one of them. Capital N is not one of them. That's why capital N is not prime. Okay? So but the thing is हमने ये कह दिया है कि इसके अलावा और कोई प्राइम है नहीं. Okay? That's where we started with. So how could there be a number which is outside this, that's prime? Okay? So once you assume something, stick to it. How absurd this seems to you, go with it. Okay? At this point, we are saying that this is the only list of possible primes there are in the world, which means that anything that's outside this set is not prime. Okay? By 1. 1 says that this is exhaustive list of prime, so capital N is not prime. The people in the third last or the third row, why is this true? Yeah.
N is not a prime number, then N must be divided by 0.
Yes. If N is not a prime number, it must be divisible by one of the prime numbers that you know. Okay? Cool. So this is kind of by the definition of composite numbers. Okay. How about the fifth one? Second row. Why could I write this? People in other rows are waving hands left and right. Go ahead, it's your opportunity. Say something. How could I say this? So just a kind of a hint in general. Okay, sometimes some things are so monstrous looking, but they're kind of the simplest things on the slide. Yeah.
By definition, if you can divide n by pi, then it is an integer.
Yeah. So since you can divide, so some pi divides n. If you divide it by n, you're gonna get an integer, right? So by definition of this divisibility, if you remember divisibility की definition ये थी कि again invisible pen, people who can see, okay, invisible pen मेरे लिए भी invisible हो गया. Okay, so if pi divides n, इसका मतलब ये होता है कि n is actually equal to pi times some k, okay, where k is an integer. This is the definition of divisibility. Okay, so this is by definition of divisibility in by 4. Okay, cool. What's next? Next step पे मैं कुछ भी नहीं कर रहा. I'm just simplifying this. I'm doing something on the next step. What am I doing? The first row. How could I justify step 7? Raise hands. How can I say this? How can I say that जो मैंने number यहाँ पे construct किया था, it's not an integer, right? A moment ago I said this must be an integer, right? लेकिन अब मैं ये कह रहा हूँ कि it's not an integer. How could I say that? It's a matter of honor, these girls. Should I give it to someone else? Yes?
You're dividing 1 by a prime number, so
Yes.
it has to be a decimal.
Yeah.
Can't be an integer.
Absolutely. That's the justification. Okay? Cool. So I divide the whole thing by pi. The first part के अंदर pi exist करता है. Okay? Which means कि वो cancel हो जाएगा और बाकी सारे primes integers हैं. तो ये वाला part integer है. Okay? This part is definitely not an integer. I'm dividing one number by a prime number. So it's not an integer plus some integer would be not an integer. Okay? So this is not an integer. लेकिन मैंने 1 minute पहले कहा है कि this is an integer, which means I have a contradiction. And that's, I mean, you stand here and you see the contradiction and then you say, okay, what have I proved? And this is justified question. I've proved opposite of what I assumed. Okay? I assumed that there are finitely many primes and I proved that there are not. There are not finitely many primes. There are infinitely many primes.